Yes. Yeah, hello everyone. Yes, I'm Daniel. Thanks for coming to AMD Dev Day. Today I'm going to talk to you about why is everyone doing reinforcement learning. For you guys who don't know me, I work with my brother Michael, who's also here, and we allow you to train and run LLMs locally, and it also works on AMD GPUs. So we collaborate with all the large model labs around the entire world, and yeah, you can go to our Hugging Face page to download all the latest models, and we fix bugs in them as well. We just surpassed 100 million total monthly total downloads on Hugging Face. We have around 86,000 total downloads that are uploaded to Hugging Face that use our models to fine-tune. And we have, 47,000 GitHub stars. We also contributed many bug fixes, including a gradient accumulation bug fix that we announced on Twitter last year. We work with Hugging Face and OpenAI on gpt-oss. And we also work with all teams around the world to make AI much more accessible and much easier for everyone. But today I'm going to talk about reinforcement learning. So the first question is, what is reinforcement learning? Imagine you have many, many fields like trading, games, math, and many instances and many industries. And the whole goal of reinforcement learning is to allow RL to beat these industries and put it all into the model. So there is this chart. I'm not sure if you guys saw this, but it's a trend of showing models getting better and better and better. This is a linear, this is a log scale plot. If you go to, if you see more closely, during around last year, around I think it was July last year to around August, O1 got released, and we saw this reasoning jump of models, and this shows you that reinforcement learning does increase performance dramatically. With RL, for example, with all these methodologies, you can essentially use RL to make all of these industries and these methodologies work. For example, with RL, in the trading example, if you have more profit, that is actually very good. If you have some loss in profit, then that's not good. So these are the reward functions that you actually implement inside of the RL algorithm in order to make it to learn. For example, the 2048 game, if the game finally gets 2048, that is very good. So you want to reward this. If you get stuck in some sort of infinite loop, that is not very good. If you failed executing the game or you get 1024, that's OK. But if you failed executing and did some Python exception error, that is definitely not good. So during the RL algorithm, you will essentially penalize bad actions, and you want to reward good actions. For maths, for example, if you get the correct answer, that is very good. If you get an incorrect answer, that is definitely not good. And if somehow the symbols match during the RL, during the execution of the math algorithm, that's also very good. And the whole goal of RL is you want to extend this to every single game, industry, example in the whole entire world. For example, extend this to the weather prediction, extend this to writing AI code. I'm not sure if you guys have heard of the AI intelligence explosion. The goal is if you can use RL to automate AI research, then the goal is this AI can get to somehow AGI. And that is why many large labs, in fact all of the large labs, are trying to spend resources on RL because the hope is you can get to AGI by automating every single task available in the entire world. We also collaborated with OpenAI during the dev day onto the 2048 example. So essentially, you can show by training and reinforcement learning on gpt-oss, you can actually play the game very well. And for example, for the 2048 game, by using RL, you can consistently beat an unfine-tuned model. And for example, if you win the 2048 game by getting 2048, you should reward this. And if you somehow the game goes on forever and never terminates, you should penalize this. And if you get maybe 1024 or 512, then you should reward this a little bit as well. We have a notebook for you to try as well. And we also have another example. For example, automatic kernel creation. So essentially, if you have an AMD GPU and you want to make matrix multiplication faster, for example, you can actually create automatic kernels by using RL. And the goal is you want to make the kernels much faster, not must terminate, and the results must be exactly good. So you can essentially use RL for many use cases. If you have seen a latest Dawakash podcast, Andre said RL is kind of like sucking supervision bits through a straw. We do have a sticker which kind of is like that. And he also said RL is terrible, but everything else is much worse than RL. So there's a lot of like misconstruing of what he's trying to say. So Andre is essentially trying to say that RL does work somewhat, and it's the best tool we have in the toolbox currently to reach to make models much better and much smarter. Thinking Machines released a recent blog post as well, the law without regret, and they show that you can actually do RL and reinforcement learning by using very less resources via LoRa fine-tuning. What LoRa fine-tuning does is you only need to add a few extra weights to the entire model, and you don't actually need to fine-tune or train the entire model. For example, if GPT-4 was like 1 trillion tokens, 1 trillion parameters, you don't need to train every single one of the parameters of the 1 trillion model. Right? You only need to add 10 million parameters or 100 million parameters, very small portion of the model, and you can just train these small parameters. But the trick was this didn't really work very well. And in the Thinking Machines paper blog post, which we also collaborated on, showed that if you select good parameters, for example, a good learning rate, good LoRa alpha, you can essentially you can still get very high accuracy. So the trick for RL is you need to be very careful of the parameters you select for LoRa during RL. For GPT-oss, when you do reinforcement learning, we also provide the fastest inference for GPT-oss. So the trick of RL is you need to do inference, then training, then inference, then training. And so the biggest bottleneck in RL is you need to actually do inference. Essentially, you need to make inference much faster. And like we showcase with GPT-oss, you can make inference much faster through Unsloth. And we showcase there is no accuracy degradation, and we allow you to do 16-bit training and 4-bit training as well. So for example, the green bars show the latest version of Unsloth, which allows you to increase inference speed dramatically. And the gray bars was our previous version that we had. You can also extend long context. You could do ultra-long context training. So one of the biggest issues if you try Codex or Claude Code is the context length can be quite limited. Gemini does have a very long context length. But through RL, the goal is you want to make the RL algorithm just learn over time and execute code within this long context window. And so the goal is you want to have very, very, very long context in order to understand the problem much better. And we showcase that you can actually do very, very long context training by using some mathematical tricks. And the trick is you don't need to reduce any accuracy whatsoever. So the goal is you want to offload all of the weights into CPU RAM and then use the GPU memory as temporarily offload it and then put it back into GPU memory. And the trick is during this procedure of handing back to the CPU and GPU, you need to be very careful of how to manage the time communication. And essentially, we show that you can actually extend long context for RL. And you can see this graph. The dark green line is much less memory usage and also very long context. Recently this year, also other work that we have, DeepSeek R1 was the first model to showcase you can use GRPO or a specific RL algorithm. And the trick was they used GRPO to train DeepSeek R1 and released this earlier January. And it kind of shocked the entire industry. Another lab could also do RL. Previously last year, it was only OpenAI's O1 model which showcased you can use reasoning models. And so earlier this year, we released dynamic 1.58-bit GGWEFs for DeepSeek R1. And essentially, we showcased that you can actually quantize the model down to 1 bit, or even 1.58-bit, 2-bit, and the model does pretty well. For example, if you use the original R1 model, the original 8-bit model is on the left. This is like a Flappy Bird, like a approximation of a Flappy Bird game. And in the 1-bit version, which is 1.58-bit, still does very, very well. But we show that you can't just quantize the entire model down to 1.58-bit. This actually does not work. If you quantize the model down to just 1 bit, the model will totally fail. It will not respond to anything. It will just go gibberish. So the trick is you need to dynamically select which layers you want to quantize. And so that is why we call it the dynamic 1.58-bit quantization. And essentially, some layers you must leave in 8-bit, 6-bit, or some higher bit. And then some layers you can leave in 1 bit. And essentially, you can showcase this works very well for DeepSeek R1 as well. And this methodology works for any single reasoning model, any single language model, and we have lots of uploads for any single model. Another way to see this is recently we showcased benchmarks for Ada Polyglot. So 80 polygon is a very popular benchmark which showcases coding performance. And you can see that all of these models, if you quantize them down, it still does very well. So the green bars are the quantization levels that we showcase. And so, for example, the lower bit models that we quantize down still work relatively well. And so, it does not mean that if you quantize the model down to 1 bit or 2 bit, it just goes to 0% accuracy. That's incorrect. You can still retain accuracy of the model. So, depending on how much disk space you have, you could, if you have a very not very good GPU or not very good hardware, you can essentially utilize a 1-bit model or a 2-bit model. And if you have very good GPUs like the MI300, then you can run the 8-bit model, and you can run this entirely locally as well. We also support all transformer models, including text-to-speech, BERT, vision language models, and we are the most efficient reinforcement learning framework with the least memory usage and also the fastest. And we also fixed critical bugs in models, and we essentially increase accuracy dramatically. We also upload all our models that we do, like dynamic quantizations, and all of our bug fixes to our Hugging Face page. And you can essentially find out dynamic bits and bytes models for fine-tuning. You can do this for reinforcement learning. And we will always update every single model. For example, we collaborate with the Quan, Mistral, Llama teams. And essentially, you will have the latest updates. So if there's some sort of bug in the model, we will definitely fix it and upload it to our Hugging Face page. We also have a notebooks page. So essentially, we upload all of our notebooks to our docs page. We essentially support all reinforcement learning types and GRPO specifically. And essentially, if you want to do reinforcement learning, definitely check Unsloth out. And also recently, we supported AMD GPUs. So AMD GPUs we found to be extremely well and very, very fast for training. So we train specifically on the MI300X. And with now Unsloth, there were some installation issues, but we worked with AMD to make the installation process much, much easier. So if you do pip install Unsloth AMD, essentially you can install Unsloth on AMD GPUs, and it will be a seamless experience. So you don't need to do any special extra installation scripts and stuff. So definitely check this out. We haven't announced it that much, but during the workshop, which I will do about RL and AMD GPUs, you essentially can train an AMD, using the MI300X, you can do reinforcement learning during the workshop. And essentially, AMD support has been an extremely important milestone for us. And essentially, we can branch out and use other GPUs as well. And the MI300X, AMD does have free credits, so definitely get the free credits for the GPUs as well. And yeah, the workshop is around 1 p.m. after lunch. And I'm going to be talking about reinforcement learning, how to actually do reinforcement learning on a MI300X GPU. And an MI300X GPU has 192 GB of VRAM, so you can fit gigantic models. We'll be using GPT-oss, so OpenAI's open source model, to do automatic kernel creation, and also the 2048 game. And the whole goal of reinforcement learning is you can solve these games and solve these methodologies in order to win against and get extreme high accuracy. Yeah. Thank you so much. We also have stickers if you want. We have a lot of stickers available. Definitely star us on GitHub. You can catch me up after the talks as well. And thank you so much for inviting me. Yeah.